Hello students, welcome back. In the last lecture we started with the revision of our first chapter, which is motion. Now in the previous lecture we discussed what are scalar quantities, what are vector quantities, and we discussed the meaning of rest and motion. Now in this lecture we are going to study another concept, we are going to revise another concept, which is distance and displacement. So please write down the heading distance and displacement. I hope you all must be knowing the meaning of distance and displacement and what are these physical quantities. So we write distance and displacement. So first of all, what is distance? Distance is nothing but the length of the actual path covered by the body during its motion. For example, there is a person, he goes from city A, let's say this is city A, he goes from city A to city B, okay, by traveling a distance of say 5 kilometers. The length of this path between point A and point B is 5 kilometers, okay, and then from city B he goes to some city C, let's say by traveling 10 kilometers, and then from city C to city D he goes to city D by traveling a distance of say 12 kilometers, okay. So this is how he travels from city A to city B, from city B to city C, and from city C to city D, okay. So now if we want to know what is the distance that he has traveled, so what we need to do is we need to simply add the length of the paths that he has traveled. The length of this path from A to B is 5 kilometers, and the length of this path from B to C is 10 kilometers, and from C to D is 12 kilometers. So to calculate the distance, we just add the length of all paths, right? So we will have distance is equal to 5 kilometer plus 10 kilometer plus 12 kilometer. So it will be 5 plus 10 15, and 15 plus 12 is 27 kilometer. So this is the distance covered by him during its journey. So you can see that there in this discussion we did not mention about anything about direction, because distance is a scalar quantity, and if you are going to ask me that what is the distance between Rudrapur city and Delhi, then the distance is 250 kilometers. We need not mention the direction, that if you go by this direction only, then the distance will be anything 250 kilometers. So distance is a scalar quantity and we need not mention anything about the direction. But if we talk about the displacement, then displacement is defined as the shortest distance between the initial and the final points. So in this example, what the salesman do? He travels from city A to city B, then to city C, and then to city D. So now if you want to know the value of displacement, so what we need to do? We need to check the initial point and his final point. So in the initial, the salesman or the man was presenting in city 1, and in the final state is this, where the man is present at point D. So this is the initial point of his journey, and this is the final point of his journey. So the shortest distance between the initial and the final point is called as the displacement. So now if we want to calculate the displacement, then what we should do is we should see the shortest distance between these 2 points, and the shortest distance between any 2 points can only be a straight line. So this straight line represents the magnitude of displacement. This is the displacement, and displacement is a vector quantity which is, and the direction of it is from initial point to the starting point. Since this is the initial point A and this is the final point D, so the direction will be from A to D like this, and the magnitude of this, that this clearly. So please write down the definition of distance and displacement. Okay, let us mention all the points in the tabular form itself. So please draw a table, and in this table only we will discuss all the important points, right? So draw a table like this and write here distance, and in this column write here displacement. Fine. So I am repeating the first point. Please write the first point. The first point will be the definition itself. So here write in this under the column distance. The first point is the actual length of the path. The actual length of the path traveled by a moving body. The actual length of the path traveled by a moving body, irrespective of the direction, traveled by a moving body, irrespective of the direction, is called the distance traveled by the body. So to calculate the distance, you need not do anything, you just need to calculate the total length of the actual path which is covered by the body. So this is the actual path that is covered by the body. So the length of this path will represent the distance traveled by the body. I hope I am clear to everyone, right? Now under this column displacement, the first point, right, the change in the position of a moving body. Okay, like write it like this. The first point, please cut it if you have written anything. I am going to tell you the easy definition. Okay, so write the shortest distance between the initial and final positions. The shortest distance between the initial and final positions of a moving body is called its displacement. The shortest distance between the initial and final positions of a moving body is called its displacement. So here the initial point was point A and the final point was point D. So the shortest distance between these 2 points is the displacement, and the shortest distance between any 2 points can only be a straight line. So we have drawn a straight line like this, and the magnitude of this length represents the magnitude of displacement, and because it is a scalar quantity, the direction will be from point A to point D. Fine. So please write down the next point. The next point says distance traveled is a scalar quantity. Distance traveled is a scalar quantity. Distance traveled is a scalar quantity. फिर इसके अंदर लिखना second point, displacement is a vector quantity. Displacement is a vector quantity. So distance traveled is a scalar quantity and displacement is a vector quantity. And because it is a vector quantity, it must be having a direction we discussed in the last class. So that direction of displacement vector is from point A to point D, that is from initial to the final point, right? Now write the third point. The third point says distance traveled is always positive. Distance traveled is always positive. Distance traveled is always positive. That means if you are traveling from one point to the another point, then distance can never be zero or it can never be negative. It will always be a positive quantity, right? If you are traveling from point A to point D, then distance cannot be zero or it cannot be negative. It is always a positive quantity, right? So distance traveled is always positive. And now, so let me write here, always positive. While displacement, under the heading displacement, right, displacement may be positive, negative or zero. Displacement may be positive, negative or zero. मतलब जो हमारा displacement है, it can be positive, negative or zero. It can take any value, any positive value, negative value or zero. When it will take zero value, when you are traveling from some point and you return back to that point. For example, if this salesman travel back from city D to city A like this, if he travels back from city D to city A, then his initial point will be A and the final point will be A. So since both the points are the same, that means his displacement will be 0. Fine. I hope this is clear to you. So displacement can be positive, negative or 0. When the initial and the final points are same, then the displacement of a body is 0. Right? Now write down the next point. The next point says distance traveled is always greater than or equal to displacement. Distance traveled is always greater than or equal to displacement. That means distance is always greater than or equal to displacement. ठीक है? So that means जो हमारा distance होगा उसकी वैल्यू हमेशा और हमेशा displacement से ज्यादा ही होगी. This is obvious because जो हमारा displacement है वो shortest distance है between initial and final point, जबकि distance actual length है part की, so it will always be greater than or equal to displacement. Right? Now under the column displacement, please write fourth point. So displacement is always less than or equal to distance traveled. इसी का उल्टा लिख देंगे यहाँ पे, displacement is always less than or equal to distance traveled. Displacement is always less than or equal to distance traveled. I hope I am clear to everyone. So these were few basic things that you should know about distance and displacement. Now let us practice some numerical problems based on distance and displacement. So the first question says a particle, there is a particle moves on a circular track. A particle moves on a circular track of radius r. What is the value of distance and displacement when, first part is when it covers half of the circle, when it covers half of the circle, and the second point is when it covers complete, when it covers one complete revolution, when it covers one complete revolution. I hope everyone can do this question. Please first of all write down this question and then let us discuss this. So the question says there is a particle that moves on a circular track of radius r, and we have to calculate the value of distance and displacement when it covers half of the circle and when it covers one complete revolution. So I am going to erase this question now. Let us do the solution. Please pause the video and try the question by yourself and then check your answers. And if you have any doubt, I am going to discuss the solution here. Okay? So I am going to discuss the solution. First part, when it covers half of the circle, there is a particle. Let's say this is a circle of radius r, So when it will cover half of the circle, the initial position of the particle will be this and the final position of the particle will be this. And this radius is given as r. Okay? So what will be the value of distance? हमने पढ़ा है कि distance is what? Distance is the length of the actual path covered by the particle. So ये path particle ने cover किया है, so हमें इसकी length calculate करनी है और इसी की length जो होगी वो distance के बराबर होगी, right? So distance will be equal to what will be the length of this path? The complete length or the circumference of the circle is given by 2 pi r and this length will be half of the 2 pi r. So distance will be 2 pi r by 2 and therefore the distance will be pi r units. ठीक है? This is the value of distance. And now we have to calculate the displacement. What do we know? Displacement is the shortest path between the initial and the final point. This is the initial point and this is the final point. So the shortest path will be a straight line connecting these two, and because this is the equal to the diameter of the circle, therefore displacement will be equal to diameter of the circle and therefore displacement is equal to 2r units. I hope this is clear to everyone. So this is the solution to the first part. And now in the second part it says that I will write here initial and this is final. Okay? Now in the second part it is saying what will be the distance and displacement when the particle has covered one complete revolution. That means let's say particle starts from here and it again comes back to here. That means the initial and the final points are same. So what will be the distance in this case? Distance will be equal to the complete circumference of the circle, which is equal to 2 pi r units. Fine? And displacement will be equal to 0. Right, very good. Displacement will be 0 because initial and final points are same, so the distance or the shortest distance between these two points is 0. Fine. So please, this is the solution. Please copy it and then we shall move to our next problem. Right? I hope everyone has copied this. Now I am going to discuss question number 2. The question number 2 says a particle moves on a circular track of radius 5 meter. ठीक है? A particle moves on a circular track of radius 5 meter. What will be the distance and displacement? What will be the distance and displacement of the particle? What will be the distance and displacement of the particle when it moves through angle of 60 degree, second when it moves through angle of 90 degree. So please write down this question and try to solve it by yourself. and then we will discuss the solution, right? So the question says a particle is there which is moving on a circular track of radius 5 meter, and we have been asked what is the distance and displacement of the particle when it moves through angle of 60 degree and when it moves through angle of 90 degree. So I am going to erase the question now and we will discuss the solution. So now we are going to discuss the solution. The solution to part 1. In part 1, the question says the particle is moving on a circular track. Okay? Let me draw it once again. So this is a circle and the radius of the circle is 5 meter. Suppose the particle was present initially here, okay? This is the initial position, and in the first part it is saying we have to find the distance and displacement when it describes an angle of 60 degree. That means somewhat here the particle will reach finally, and the angle that we have described at the center is 60 degree. And now we need to calculate the distance and displacement. So how do we calculate the value of distance? Again, distance is equal to length of the actual path traveled. This is the length of the actual path traveled. So we have to calculate the length of this arc. Okay? Acha, we know one formula that theta is equal to r upon radius. Theta is equal to r upon radius. So length of the arc will be equal to theta into radius. So that means if we want to calculate the length of this arc, we need to multiply the angle subtended at the center multiplied by the radius. Radius is given as 5 meter. And what is the angle subtended at the center? The angle subtended is 60 degree. And because we are going to multiply 60 degree with the radius, so we will have to convert this angle from degree into radian. ठीक है, तो 60 डिग्री मल्टीप्लाई बाय पाई अपॉन 180 डिग्री से मल्टीप्लाई करते हैं रेडियन में कन्वर्ट करने के लिए. सो दिस इज थीटा मल्टीप्लाई बाय द रेडियस व्हिच इज गिवन एज 5 मीटर. सो डिस्टेंस विल बी इक्वल टू 6 3 are 18, so it will be 5 pi by 3 meter. This is the value of the distance covered by the particle, right? And now we want to calculate the displacement, right? So again, what do we know? We know displacement is the shortest distance between the initial and the final point. This is the initial point, this is the final point, and the shortest distance between them will be a straight line. Now we need to calculate the length of this line. So now if you see this triangle, in this triangle, this length is 5 meter because this is a radius and this is also a radius, so this is also 5 meter. Okay? And because these two sides of the triangle are equal, so these two angles must also be equal, right? And because this is 60 degree, the sum of these two will be 180 degree minus 60 degree equal to 120 degree, right? And because these two angles are equal, so this angle must be 60 degree and this angle must also be equal to 60 degree. So now in this triangle all the angles are 60 degree. That means this is an equilateral triangle, and we know that in an equilateral triangle all the sides are equal, therefore this side will also be equal to 5 meter. And because this length represents the displacement, so displacement will be equal to 5 meter. I hope this is clear to everyone. Okay? So this is the solution of the first part, and in the second part the question says what is the distance and displacement when particle moves through 90 degree. Let me erase the figure. Please copy it if you have not. Okay? I am going to modify this figure now for 90 degree. In case of 90 degree, I think it's more easy initial position of the particle and this is the final position of the particle. This angle described as 90 degree. ठीक है? So what will be the distance? Distance will be the length of the arc which is covered by the particle. ठीक है? Again, arc is equal to theta into radius. What is theta? 90 degree. So we will convert into radian, multiply by pi upon 180 degree. So this is theta multiply by radius which is 5 meter. So it will be equal to 5 pi by 2 meter. Fine. So this is the distance. And what will be the displacement? The displacement will be equal to the length of this line. The distance, shortest distance between the initial and the final point is this. So what will be the displacement? How do we calculate this displacement? The displacement can be calculated by considering this triangle. Okay, this triangle is a 90 degree triangle. So we can apply Pythagoras theorem. Okay, this length is 5 meter. This length is also 5 meter. So by using Pythagoras theorem, the length of this will be under root of 5 square plus 5 square. That means under root of 50. So this length is equal to root 50 and therefore the displacement will be root 50 meter. I hope everyone has got this. Right? So it was all in this lecture and now in the next lecture we will start the revision of the concepts speed and velocity. Okay? Till then take care. Bye.